Dear students, we are going to start a new chapter called matrices. Matrices are one of the most important tool in mathematics. It is used in different fields like cryptography, cost estimation, result analyzing, for preparing electronic spreadsheet for personal computers, etc. In mathematics, it is mainly used for solving system of equations. So in this chapter, we are going to study about different type of matrices, how to add two matrices, how to multiply, etc. So let us start this chapter with the definition of matrix. Matrix. Matrix is rectangular array of numbers. Array of numbers or functions. Rectangular array of numbers or functions means arrangement of numbers or variables in a rectangular form. Okay, for example, let us consider one matrix. A equal to a matrix 5, 8, 9, 3, 4, 8. This is one example for matrix. Another example was B equal to a matrix X, Y, A, B. Here I am arranging numbers in a rectangular form. Here I am arranging variables in a rectangular form. Now these two are example for two matrices. So actually we are arranging elements or variables in rows and columns. So in this matrix, how many rows are there for this matrix? This one is it's row 1, this is row 2, and this one is column 1 of this matrix, column 2, and this is column 3. So 2 rows and 3 columns are there. So we are arranging numbers in 2 rows and 3 columns. So in this matrix we are arranging variables in 2 rows and 2 columns. Suppose a person X is having 5 number of pens, 4 number of books, 3 rubbers, and 2 pencils. Actually, these are datas. Can we represent these datas in a rectangular form, in the form of a matrix? We can represent like this. 4 datas are there, so we can represent rectangular form as 5, 4, 3, 2. This one is one way. We can take it as A. We denote capital letters for representing matrix and its elements by small letters in case of variables. Okay, so this is one way, and we can represent this datas in this way also. 4 elements are there, so 5, 4, 3, 2. This is also a rectangular form, right? In this case, we are representing in 2 rows and 2 columns. So in this case, we are representing in 4 rows and 1 column. And third way is 5, 4, 3, 2. Right, 1 row and 4 columns. That means we can represent datas in different forms, different rectangular forms. Now we have to study about order of a matrix. If a matrix has got m rows and n columns, then order of the matrix is m by n. That is definition. If a matrix has got m rows and n columns, then order of the matrix is m by n. For example, let's one matrix A equal to 5, 8, 9, 3, 4, 3. So can you find order of this matrix? This matrix has got 2 rows, right? This is R1, this one is R2. How many columns are there? There are 3 columns. So order of this matrix is 2 by 3. 2 rows and 3 columns. 2 by 3 we denote by this symbol. This is not 2 into 3. We read it as 2 by 3. But we write it as 2 into 3. Okay. So in general, if a matrix has m rows and n columns, then order of the matrix is m by n. Okay. Now we can do some questions. And so one matrix A, 3, 4, 5, 4, 7, 9. What is its order? 3 rows are there and 2 columns. So order's matrix is 3 by 2. Order we'll write in this corner, 3 by 2 matrix. So this one is a 3 by 2 matrix. Second one, B equal to 3, 4, 9, 5, 4, 3, 3, 4, 8. 3 rows and 3 columns. So order's matrix is 3 by 3. 3 by 3. And this one, 2 rows and 3 columns. So order is 2 by 3. So it is very simple to find order of the matrix. Okay. Now consider matrix A once again. So order is 3 by 2. How many elements are there in this matrix? There are 6 elements. That is 3 into 2. Order of matrix is 3 by 3. How many elements? 9 elements. 3 into 3. So order of matrix is 2 by 3. How many elements? 6 elements. That is 2 into 3. So in general, if order of matrix is m by n, then how many elements are there? There will be m into n elements. Right. For example, if order of matrix is 5 by 4, how many elements are in that matrix? There will be 20 elements. 20 elements. We can expect question reverse also. If there are 20 elements, how many possible orders it can have? That means how many different ways we can represent 20 elements in a rectangular form. One way is 1 by 20. Means 1 row and 20 columns. It's a rectangular form. And second way is 20 by 1. Third way 2 by 10. And fourth one is 10 by 2. Fifth one 4 by 5. Sixth one 5 by 4. Means we can represent 20 elements in 6 different ways. Take one question. If a matrix has 25 different elements, what are the possible orders it can have? This type of question you can expect for 1 marks. So 25 elements are there. How many ways we can represent these 25 elements in rectangular form? So one way is 1 by 25. Second one is 25 by 1. Third way 5 by 5. Only 3 ways, right? So we can represent 25 elements as 1 by 25, 25 by 1 and 5 by 5 ways. Now, next topic, general form of a m by n matrix means how we can represent generally a m by n matrix. M by n means m rows and n columns. So we can represent like this. You can use capital letters for representing matrix. A equal to A11. A11 is first row, first column element. Then this element will be A12, first row, second column element. Then A13, etc. How many columns are there? N columns. So last element will be A1n. Now second row A21. Second row, first column A21. And this element is A22. And this one is A23, etc. Last element in second row will be A2n. Then A31, A32, etc. A3n. Like that it goes. So last row, how many rows are there? M rows. So last element AM1, AM2, etc. And this will be AMN. So there are M rows and N columns. Order's matrix is M by N. That we will write here. This is one way. One more way is the same matrix we can represent like this. It's equal to matrix Aij. It's very simple. Matrix Aij, where Aij represent all these elements. So order is M by N, and I varies from 1 less than or equal to I, less than or equal to, actually I represent number of rows. How many rows are there? There are M rows. So 1 less than or equal to I, less than or equal to M we want to write, and J, 1 less than or equal to J, less than or equal to N, because number of columns are N. So generally we can represent matrix in this form. From this section we can expect a question like this. I construct a 2 by 3 matrix whose elements are given by Aij equal to 2i plus 3j. That means you have to construct a matrix. Its order is 2 by 3. Means 2 rows and 3 columns. So we can do like this. First you have to write its elements. So 2 by 3 means there should be 2 rows and 3 columns. So elements are A11, A12, A13, then A21, A22, A23. 2 rows and 3 columns. Now we have to find all these elements separately. So what is A11? Aij is given as 2i plus 3j. So A11 means I equal to 1 and j equal to 1. So this, here you have to substitute. In place of I, you have to substitute 1, and in place of j, we have to substitute 1. So it will be equal to 2 into 1 plus 3 into 1. 2 plus 3, answer equal to 5. Now A12, same way you can find A12. 2 into 1 plus 3 into 2. 2 plus 6. 2 plus 6 equal to 8. Now A13 means 2 into 1 plus 3 into 3. 9 plus 2, 11. Now A21, I equal to 2 and j equal to 1. So 2 into 4, 4 plus 3 equal to 7. Now A23, A22 means I equal to 2 and j equal to 2. So 2 into 4, 4 plus 6. 4 plus 6 equal to 10. Now last element is A23, I2J3. So 2 into 4, 4 plus 9, 3 into 3, 9. So 4 plus 9 equal to 30. After getting all elements, we have to write a matrix like this. So elements are 5, 8, 11, then 7, 10, 13. So answer. Order matrix is 2 by 3. We can do one more question. Construct a 2 by 2 matrix whose elements are given by Aij equal to modulus of 2i minus 3j by 2. You have to consider 2 by 2 matrix. So first we will write its structure. A equal to A11, A12, A21, A22. If this question is for 1 mark, we can write answers directly also, no problem. So now we will find A11. A11 is I equal to 1, j equal to 1. This will substitute here. So 2 into 1, 2, minus 3 into 1. 2 minus 3 equal to minus 1, mod minus 1. Mod minus 1 equal to 1. So answer is 1 by 2. Now A12 means I equal to 1, j equal to 2. So this will be 2 into 1, 2 minus 6. 2 minus 6 equal to minus 4. Mod minus 4 equal to plus 4. Plus 4 by 2 equal to 2 will get. Now A21. 2 into 2, 4. 4 minus 3, 1. 1 by 2. Last element is A22. That is 2 into 2, 4. 4 minus 6. 4 minus 6 equal to minus 2. Mod minus 2 will be plus 2. Plus 2 by 2 equal to 1. So matrix A is equal to 1 by 2, 2, 1 by 2, 1. So dear students, we have studied how to construct a matrix, how to find order of a matrix, etc. Now we will study about different types of matrices. Okay. Among the type of matrices, first one is row matrix. Row matrix means a matrix with one row and any number of columns. Matrix with one row and any number of columns. For example, A equal to a matrix 5, 4, 8, 9. This matrix has got only one row and 4 columns are there. You can have any number of columns. So order this matrix is 1 by 4. Another example, B equal to a matrix 2, 3, 8. 1 row and 3 columns. Order matrix is 1 by 3. In general, order of a row matrix will be in this form, 1 by n. One row and any number of columns. And second type is column matrix. Column matrix. Column matrix means a matrix with one column and any number of rows. One column and any number of rows. For example, matrix 5, 4, 8, 9. How many columns are there? Only one column. And there are 4 rows. Order of this matrix is 4 by 1. Right. Now another example. 3, 2, 5. Matrix with elements 3, 2, 5. So one column and 3 rows. So order is 3 by 1. So in general, order of a column matrix will be m by 1. Right. And third one is square matrix. Square matrix. Square matrix means a matrix with the same number of rows and columns. A matrix with the same number of rows and columns. For example, A equal to matrix 5, 4, 3, 8. So one square matrix because it has got 2 rows and 2 columns. Another example, B equal to matrix 5, 4, 9, 3, 4, 8, 1 minus 1, 2. So 3 by 3 square matrix. C equal to a matrix 2, 1 by 1 square matrix. This matrix is a matrix of order 2 by 2. We won't say 2 by 2. We will say like this, matrix with order 2. This one is matrix with order 3. Matrix with order 3 means it is a square matrix of order 3 by 3. Matrix with order 1 means it is a square matrix of order 1 by 1. Okay. Now from this section you have to study some more. That is diagonal elements. Diagonal elements. Diagonal elements of a matrix. So diagonal elements of a matrix are A11, A22, A33, etc. So consider this matrix. So what are diagonal elements? A11, A22, 5 and 8 are diagonal elements. So for a matrix, there is only one diagonal, A11, A22. This is not its diagonal. Okay. Now for this matrix, A11 is 5, A22 is 2, 4 and A33 is 2. This is its diagonal. A11, A22, A33. And for this matrix, 2 is its diagonal element. So diagonal elements are A11, A22, A33. That means there is only one diagonal for a matrix. These elements we cannot consider as diagonal elements. Okay. Now, trace. Trace means sum of diagonal elements. Diagonal elements. So what is trace of matrix A? That is 5 plus 8, 13. Trace of matrix B, 5 plus 4 plus 2, 9 plus 2, 11. And this one is 2 itself. Very important topic, trace. Now next type, that is diagonal matrix. A square matrix is said to be diagonal matrix if all its non-diagonal elements are zeros. Non-diagonal elements are zeros means all elements other than A11, A22, A33, etc. are 0. For example, A equal to consists 3 by 3 square matrix. 3 by 3 square matrix. We want to convert this one into a diagonal matrix. So first we will write its diagonal elements 5, 8, 9. All non-diagonal elements should be 0. So this is equal to 0, 0, 0, A21 0, A31 0, A32 0. This is example for a diagonal matrix. There is no such a condition that all diagonal elements should not be 0. At least one diagonal element should not be 0. That is the condition. So this 8 can be 0, no problem. Second example, can be equal to a matrix 5, 0, 0, 8. And its general definition is one. A square matrix A equal to Aij is said to be a diagonal matrix if Aij equal to 0 for I not equal to j. Aij 0 for I not equal to j. That means A12 should be 0 because 1 is not equal to 2. A13, say A13 0 because 1 not equal to 3. A21 0, A23 0 because 2 not equal to 3. Like that. So this is an definition. Aij equal to 0 for I not equal to j. So this definition you have to by heart. Okay. Next type, that is scalar matrix. A diagonal matrix is said to be scalar matrix if all diagonal elements are same. Should be a diagonal matrix. So automatically it is a square matrix and all diagonal elements should be same. For example, A equal to a matrix 5 0 0 0 5 0 0 0 5. All diagonal elements should be same and non-diagonal elements are zeros. Generally, a scalar matrix we can define like this. A square matrix A equal to Aij is said to be a scalar matrix if Aij equal to 0 for I not equal to j and Aij equal to a constant if I equal to j. I equal to j means A11, A22, A33 will be a constant. In all other cases, it should be 0. For I not equal to j, Aij equal to 0. Next type, identity matrix. A square matrix is said to be an identity matrix if Aij equal to 0 for I not equal to j. Means all non-diagonal elements should be 0. Aij equal to 1 for I equal to j. Means all diagonal elements should be same and it is equal to 1. For example, A equal to 1 0 0 0 1 0 0 0 1. This is identity matrix of order 3. We denote by I3. Okay. Suppose B equal to 1 0 0 1. This is identity matrix of order 2. We can denote by I2. What is trace of this matrix? 3. Trace 2. So what about trace of an identity matrix of order n? Trace of an identity matrix of order n is n because we have to add 1 n times, 1 plus etc. n times. Okay. Next one is zero matrix. A matrix is said to be zero matrix if all its elements are zeros. It need not be a square matrix. It can be any type of matrix. Okay. So for example, A equal to a matrix 0 0 0 0 0 0. The example for a square matrix. What is order 2 by 3 matrix? It's not a square matrix. B equal to a matrix 0 0 0 0. We usually denote a zero matrix by a letter O. O. C equal to a matrix. Okay. So zero matrix means all elements should be 0. For the interest point of view, you have to study two more different types. That is upper triangle matrix and lower triangle matrix. A square matrix is said to be upper triangle matrix if Aij equal to 0 for I greater than j. That means A21. What about A21? A21 should be 0 because 2 is more than 1. A31 equals 0 because 3 more than 1. A32 equal to 0 because 3 is more than 2. Example for an upper triangle matrix. So A11, A12, A13, A21, A22, A23, A31, A32, A33. So A21, A32, A31 should be 0. So example, A equal to a matrix 2, 5, 8, 0, 9, 9, 0, 0, 4. Okay, so here you can see one triangle. That is what is called upper triangle matrix. Then a square matrix is said to be lower triangle matrix if Aij equal to 0 for I less than j. I less than j means A12 should be 0, right? A13 should be 0 because 1 is less than 3 and A23 should be 0. So generally we can represent like this: A11, A12 should be 0, A13 0, then A21, A22, this is A23 should be 0, A31, A32, and this one is A33. So here you can see one triangle. That is what is called lower triangle matrix. So example, B equal to 5, 0, 8, 9. Right. 2 by 2 lower triangle matrix. So in case of 3 by 3, we can write like this: 2, 0, 0, 8, 5, 0, 9, 9, 9. Example for lower triangle matrix. So these are the different type of matrices. So students, we have studied about row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, zero matrix, upper triangle matrix, lower triangle matrix. In the next class, we will study its operations. Okay. So we can conclude today's session. Thank you.